Assalamualaikum warahmatullahi and a very good day to all of you. Okay, I would like to introduce myself. My name is Muhammad Zaimi bin Zainal Abidin, the lecturer in the Department of Diploma Studies, but my field of study is in materials engineering. So I'll be teaching you the material selection courses for this semester from this week to until the end of this course week. Okay, so for today's chapter will be the introduction of material selection. Okay, so the code for this course is BMFB3323 material selection. So myself and Associate Professor Dr. Zaleha and also probably Associate Professor Dr. Jaria will be teaching this course together but different section. Okay, here is the outline for the introduction to material selection. Okay, 1.1 is the introduction to the course, and then you have the material selection, which is the evaluation of materials, and then this one we need to focus to expose the student the correct way on technical report writing. Okay, especially on the reference citation. Okay, report writing is very common, but you need to know how to write it properly, and then you need to cite whatever you get a reference. And then more of a discussion with the lecturer on the given work assignment, and then you have to use the ulearn as the platform for the discussion. Okay, as for the synopsis of the material selection, this chapter or this course, okay, which is integrating all of these engineering materials which we have learned in the first year, which is include metal, polymer, ceramics, and composite, and then you need to relate them with each of these materials properties such as modulus, okay, strength modulus, which is young modulus or shear modulus. We have strength, hardness, toughness, and many more. Of course, you can relate it with the chemical resistance, for example, acid resistant, alkaline resistant, and so on. And then you need to know about the various processing techniques. Okay, processing techniques, probably you have learned in the material process, okay, or advanced material process or advanced processing in the previous chapter I think you have learned it uh, in the first year manufacturing process, that kind of the courses that you have learned. And then you have to use your capability for the problem based learning, and then you need to reinforce the concept of and the capability in applying selection of materials, utilizing materials property charts, data, and software. So in this course, you'll be concentrating on the two type of two reference books, which is the first one is HB, okay, material selection in mechanical design, and then you have engineering materials properties. So these two books will be used. Actually, you can use the previous engineering material classes books and so on. That one, that kind of thing is also familiar in this case. Okay, next, which is the learning outcome. Okay, first LO will be the explaining the relationship between design requirements, materials properties, processing, and product performance. Basically, you are doing the PDM and so on, as well as the IDP. And then for the second LO, okay, which is the course learning outcome, demonstrate in-depth technical competence to justify the suitability of a particular processing method for a specific selected material and design activity using data and charts and software. Of course, in this case, probably you don't have the convenience to use the material selection lab, since we have a online classes all this semester. So probably I'll just show you some of the demonstration and probably how to use the materials charts and properties charts and processing charts and so on. So that kind of thing you can get it in the HB book. Okay, and then for the LO3, can select the most appropriate materials and processes to be used for fabrication and commercialization. Here we're talking about mass production. So you need to use the highly optimized process the low cost, the most efficient, the what you call it, the most reliable, so that you can make the product into batches. So I'm talking about batches of not 10, probably 1,000, probably 10,000, and many more, because you are talking about manufacturing. And then the fourth one will be the communicate ideas relevant to material selection in relation with the product design and manufacturing. Here is directly to related with the PDM and as well as the IDP. And then the last LO will be perform self-directed study in getting new knowledge and skill and so on. Okay, so this one will be evaluated throughout this course. So these are the chapters related for these courses. First, we have the introduction of material selection, and then you have material selection, the design process. We have, which you have learned in the manufacturing process courses, and then you have engineering materials and their properties, which is you can relate in the first year engineering materials, and then there's also the engineering materials and their properties, which is including ceramics, polymers, metal. Some might can be related with the composite. And then the fourth chapter, which is the materials property charts. So these charts will be given either by in this slides on in this PowerPoint, or sometimes I will give you in the ULearn and so on. And then the fifth one is the material selection. First one is the basic selection strategy, and then second thing you need to know is the material indices. Material indices, you have to know, for example, the material that you have used, and then based on this property, you can use to calculate some of the material indices so that you can move along the properties charts. So this one probably you don't have any idea about this one, but you need to check back in the later chapter. And then you have the selection procedure. Okay, selection procedure, of course, you have the obvious one is ranking. Okay, and then you can have a knockout. Knockout means that you knock out all those materials which doesn't relate or doesn't comply with the design requirement. And then you have the case studies for the material selection. So this one case study will be in the assignment and so on. And then chapter 6 would be the process and process selection, which is include shaping, joining, finishing, and systematic process selection and so on. So I think this chapter is already you have learned in manufacturing process, and as well as in the advanced manufacturing process. And then the last chapter will be the materials and the environment. So for the this course we have the, of course, we have lecture, and then we have tutorial, homework, okay, and then we have assessment, of obviously, okay, which is you have two case study. Remember, these courses is highly related to the case study because it's an open-ended courses. Actually, it's an open-ended courses. But during the final exam, probably you have a very specific, or we have to narrow down uh, the question so that you can refer to the reference, okay, refer to the appendix, and then you can solve all the questions and so on. Okay, and then you have one mid semester, obviously, and then you have one quiz, and then you have one final exam. So as for degree, which is 60% will be in the final exam, okay, and then 20% will be in the mid semester exam. So attendance will be recorded using ULearn. So actually, these classes or this course will be fully online. So the timeline for you to see or to you to hear this lecture is by weeks. For example, for for today's class, okay, so you can fill in the attendance in the ULearn system from today until Sunday, for example, that kind of thing. Okay, over here is the detailed cost assessment. So you have two case studies. Each case studies is 10 marks. Oh, over here is the mid-semester exam is only 15 marks. Okay, sorry about that. Quiz is 5% and the remaining final exam will be 60%. Okay, previously probably 20% for the mid-semester exam, but this one can be adjusted because we counted for the case study to be much more heavier side. And then this is the important dates for these courses. Lecture week 3, you have case study 1. Okay, and then week 7 you have quiz, and then week 9 you have case study 1 submission. Week 9 also you have mid semester exam, or quite compact, but I think you can manage uh, uh, to do both because case study is not so difficult. It's very open. And then you have week 10 case study, the second case study distribution, and then you need to submit it by the 14th week, which is the last week. And then week 18 is the final exam. Okay. Actually, for the special notes for the must come to class on time is depending on the lecture itself. So see themselves. As for myself, is asynchronous classes, so you can see my video anytime during that particular week. Okay, it's related with the chapter, and then you need to give some comments and so on. So that I need some feedback. Okay, so actually this one is for the during the lecture where we used to use the material selection lab in the old building. Okay. Okay, so the course goal is to use the right material for the job, which is whenever you want to make a product, then you need to choose a material. That's all. And then you need to relate between the properties of material, structure, and processing. Okay, ultimately it's processing, but you need to also evaluate the product performance later on. And then the third one is to recognize new design opportunities. Okay, new design opportunities by means that when you are learning material selection, you can use it for PDM and IDP. So as for the definition of materials, a substance with specific chemical composition. Okay, here I read it out in the slide. A substance with specific chemical composition and certain physical properties, which is used as an input in production and manufacturing. Okay, so over here, what is your role as an engineer? Okay, actually, when you become an engineer, you have materials engineering, where you design the material itself. Okay, you engineer the material according to the requirement or property specification or the design requirement or whatever environment that you need to use that material. For example, you want to use that material in a salt water. Okay, so probably you can use copper or you can use brass. Okay, in the industrial term, probably you can use admiral brass. Okay, but over here in the industry, from the initial start of the process, which is material procurement, we have the procurement engineers over there, which ask the engineers at the backside at the end of the process, which is what the material that you want to buy. Okay, what material that you want to buy. Obviously, in a company or in a manufacturer, so you need to buy materials to produce a product. So that materials need to be bought by the procurement engineer. So the procurement engineer need to have some kind of the technical knowledge, and then you need to know a material knowledge, and then some of the mechanical and so on. Basically, any kind of material engineer and mechanical engineer or physics and so on can become the procurement engineer. And then from that procurement, we will go to the inventory. So over here, for example, if you buy a stainless steel pipe, and then you need to assemble it in inside a fabrication warehouse. So you need to store it in the very, for example, very safe condition. For example, stainless steel, you cannot expose it into the normal atmospheric air, which is contain water and so on. And then from that inventory, then you need to go for the initial processing. For example, for the stainless steel pipe, probably in the initial step is a long pipe, and then whenever you want to assemble or you want to do some processing, you need to cut it. You need to cut the pipe, and then you need to weld the pipe with the flange and so on. So your role as an engineer, you need to know the early process, okay, the use of the material at early stage, and then the end product, the outcome, which is the product itself. So you need to know the whole process. Okay. Normally you have learned it in the form 4 during the middle school for the periodic table. Here you have a classes of material, metallic, non-metallic. Over here, okay, over here you have transition metal. Here is non-metal. Here is almost like which one over here? You can make it into a semiconductor. Here is light metal and rare earth. Here also is a rare earth metal. So material can be divided like this one. But in case for this one is a pure elements, pure state of material. Okay. But you need to know, okay, from here you have family of materials, which is you have ceramic and glasses. Okay, here you have metal and alloys, polymer, elastomer, and hybrids, which is uh, we call it composite. So of course, in the material selection lab, okay, we have the materials universe as well as the process universe. Okay, then over here you have, if you selected metal and alloys, okay, so you have classes of materials, classes of metals and alloys over here, including steels. Steels is basically iron, okay, and then you have copper alloys, for example, brass, aluminum alloy, titanium, nickel, zinc alloys, and so on. So you have a list of material or list of material database. Actually, you can see it in the website, for example, MedWeb and so on, for online resources. For the this courses you can use in the material selection lab, we have the software, we have a CES EduPack for that, so that you can browse through all the materials, okay, in the database. Basically it's just like googling and Wikipedia and so on, but much more detailed because you have a very specific material properties. For example, coefficient of friction, properly wear, and then you can have a stiffness, hardness, and so on. And then you have members. For example, aluminum alloys, you have 1000 series, 2000 series, until 8000 series, depending on the application. For example, the most common one is 1000 series because it's almost like 90%, more than 90% aluminum. Okay, so if you increase the numbers of series of aluminum alloy, you have 2000 series. Probably you can add with the zinc alloy, add zinc into the aluminum alloy, and so on. As you increase the number of series, probably you can have a lot of alloying element inside the aluminum alloy. Okay, alloy the aluminum, which is become the base, and then you can add magnesium, you can add copper, you can add silica, and so on for the alloying element. So this material, according to the numbers of series over here, you have different application. For example, the most common one is 1000 series. Okay, normal product. For example, the window frame on your in your home. The 2000 series and 3000 series slightly have a better strength in terms of tensile strength, but it's not so much different. But probably you can increase the property or increase the efficiency or increase the corrosion resistant behavior and so on. While you have the 7000 series and 8000 series with a very specific application. Here you can refer to the ASTM metal handbook. Sorry, ASM metal handbook. If you get your hands on those handbooks, please read it very carefully, yeah, because this one, the handbook is, you can have a various kind of application. So here you can refer to the ASM Metals Handbook. I'm not sure which volume. They have more like 20 volumes. So you have corrosion metal and non-ferrous metal and so on. That kind, each of that term is having a whole volume like this thick. Okay, then for example, if you choose 6000 series, so these are the attributes. So aluminium 6463, so you have the material properties, thermal, electrical, optical, corrosion, and so on. So we need to do some documentation. Of course, when you buy something, you have to check at the back for the specification and also ingredients. For example, if you're buying food, okay, you're not sure what are the ingredients in the food. So same also for this one. If you buy something, you need to know what kind of material inside it so that you can know, for example, this material is functioned properly as a product. So of course, when you make a product, you need to know a lot of things, and then you need to compare a lot of things, a lot of material. So of course, you have aluminum 6000 series, you have various series, aluminium 6060, and so on. So each material have a difference, probably almost similar properties in 6000 series, but different application, different properties, and so on. So you can narrow down this material. Of course, if the product says you need to use 6000 series, the best term is which 6000 series. Okay, so over here you have the material development chart. Okay, from what, 100,000 BC. Actually, the material that we use or produce or make in the course of a 100,000 years, for example. So of course, the most common material in this world probably wood, rocks, okay, soil, and then stones, gold, diamonds, and so on. And then later on, when you are trying to produce or trying to use something, then you might have an idea. For example, if you want to make an axe, stone axe, you have to use axe made from stone. It's actually not made from stone. You actually chip from the whole block of stone, and then you have to chip it using a chipper. Okay, that chipper must be used. For example, you can use stone to chip through a stone and so on. And then you need to use wood to hold the axe, the stone axe, and then you need to use the vine, okay, vine wood to bind the both stone axe and also the handle and so on. And then of course, if you see towards the 15th century, you can see the development of using rubber. Okay, here people start to use polymer as well as early as the stone age and so on. Of course, it depends on the application and particularly what product and what are the functions. So in the current modern age, in the current modern age society, probably we can use metal, alloys, we can fabricate or we can design the materials and so on. We can use composite, we can use uh, what you call it, advanced material, nanomaterial, okay, nanomaterials such as carbon nanotube and also graphene and so on. So that particular material, so you have a list of material which is increased over these years, is like 116,000 materials. Actually more than that, more than that. Okay, because I'm a material engineer, and then also I also produce some kind of the noble material, for example, quaternary alloy, and then the polyalloy and so on. So here is the evolution of material. Okay, sorry for moving, my back hurts. Over here, you can see the usage of polymer, elastomer, composite, ceramic and glass, and metals. Okay, prior to the Iron Age, most of humans, okay, use polymer, elastomer, for example, wood, skin, fiber, and then to make houses using straw bricks and so on, and then ceramic glasses. So in the later years, okay, we tend to make a very specific or technical materials or advanced materials to be used in a very specific way, so that you can have a lot of this metal to be combined together, and then polymers to be used in a very, not, I'm not saying a very weird way. I'm saying that you can use a polymer in a various kind of application. For example, previously you use vacuum, you make vacuum using metal, and then nowadays you use polycarbonate and so on. Okay, that kind of thing. So it's actually not 2 minutes questions. It's actually question for each of you. Okay, not in pairs. Name two products and the material used to manufacture them in the various industries. Simple product, for example, pencil, mechanical pencil. So as for the mechanical pencil, okay, previously you have wood pencil and then you have a graphite inside it. So that one is the most traditional one. And then you can have a mechanical pencil. When you have mechanical pencil, you have to use spring, you have to use cover, you have to use the gripper which is made from the alpha gel, and then you have to use different kind of plastic. For example, the outer case should be in form of made from polycarbonate, which is very higher toughness and then higher tensile strength and fatigue strength, and also bending strength. And then inside it, when you have the ink, you need to use polypropylene. Okay, easy to mold and then easy to inject the ink inside it. Of course, you need to relate with the chemical resistant, and then the ballpoint of the pen should be made from the, I think, stainless steel alloy. And then of course you have the grip of the pen made from the alpha gel so that you can ease up your hand when you are writing so much, for example. And then of course the lead itself made from very thin graphite lead. Okay, not lead, it's actually graphite. Lead is plumbum, but the lead for the mechanical pencil is actually graphite. And you have the rubber. Okay, you have both. Either you can use the conventional rubber, or you can have also the synthetic rubber as a, you know, to synthetic rubber for the to remove to remove the graphite and so on. They call it kishikomu and so on. Okay, and then another one. How does an engineer able to be engineered? Okay, engineer the materials into product successfully. Of course, over here I'm talking about the whole process of making product. But in order for you to know this one, you have to go through these chapters. Okay, these courses all along. And then engineers versus materials. It's just, it's not just about material selection. Okay, of course it's about material selection, but also you need to know in terms of economics. Okay, you can make a very expensive and expensive chair, or you can make a very cheap chair. Okay, of course the material selection comes through into that, and then process selection and so on, and design for the aesthetic and so on. And then the role as engineers, engineers make things and they make them out of materials using processes, obviously. Okay, and then you have mechanical engineers. Okay, so you can use metal and alloys, polymer elastomer, ceramic glasses, hybrid composite, and so on. And then you can use the material in the aerospace and motorsport, sorry. Okay, for example, in the aerospace, for you to producing an jet engine, actually, you have to use a various kind of material. For example, you have to use refractory material. So I think you have learned in the engineering material refractory, which is a material strong enough to withstand the high temperature of condition, high temperature condition. For example, in the jet engine, it's like 2000 to 3000 degrees, probably 2000 degrees. And then, for example, the nozzle of the jet and then the blade of the jet, okay, jet engine. Over here, you need to use very specific material. For example, for the blade, probably we use nickel alloys, super nickel alloy is actually super nickel alloy, so that you can have a very higher hardness. Uh, of course, then higher tensile properties. Talking about gigapascal level and so on, and then high thermal resistance. For example, temperature above 1200 degrees Celsius. Okay, and then the nozzle part also, when you compress the air and then you push out the air, and then you can have very high temperature, high pressure, and so on, high velocity pressure. So over here probably you need to use nickel aluminum alloy mixed with the ceramics particle and so on. Actually in metal alloys, not just metal alloy, probably in this uh, over here you have composite alloy and so on. Okay, of course you have a polymer elastomer. Okay, polymer elastomer, for example, in the driving chains and so on, drive chain. Okay, belt drive, glass and ceramics. Of course you have bearing and so on, hybrid and composite. Okay, then you have civil engineering and architecture. Of course, different material and then different universe of material can be used in different structure. Of course, in the architecture, it's not about the aesthetic. Okay, over here, if you want to make a weird kind of structure, such as this thing, okay, this kind of structure, probably you need to calculate also for example, the loading of each segment, and then you have to know the calculation, for example, the support reaction, bending, the tensile, the shear, as well as the moment. Over here is not stable, right? So you have to calculate moment. So based on this calculation, you can choose what kind of material. Okay, as for the polymers also over here, okay, sometimes you can use polycarbonate, sometimes you can use polyester. But if you make a structure and then leave it outside, so it will be affected by the environment. So in case for the environment, sun is the very common enemy of the polymer, because it is easily to oxidize the polymers and then make it degrade, become brittle, become discoloration, and so on. Then you have ceramic glass. Ceramic glass is almost like indefinitely you can use it as a building material for the long time. As long as you don't have any physical or external force applied on this structure, for example. Or for example, you actually in buildings also, you mix with concrete, and then you also have a steel beam inside it and so on. Composite is another thing, because you have to make it from the two different material, completely different material. For example, plastic and also fiber, carbon fiber or glass fiber. So this actually is the simplest way to make a product. So make a panel. I think this one is the acoustic panel. Okay, Prof. Jai also talking about the acoustic material. Okay, and then you have a bioengineering. I think this one is mainly for the biochemical, sorry, not biochemical, biomedical product. For example, if you want to change your sockets, I mean, not sockets outside, no, socket in your body. For example, in between your pelvic and also your femur. So you have a over there you have a ball socket. You can change your ball socket. I think when you get old, then you know what kind of metal you use. Usually we use titanium based alloy, but nowadays we can have a ceramics, and then we can have mostly these two. Plastic, no way. And then for plastic elastomer, probably you can have a jig or restrainer inside your teeth and so on, that kind of thing. Glasses, of course, ceramics, of course, it's being used. Hybrid composite, not so sure, but it can be used. It's quite newer for this kind of composite to be used inside your body. Over here, this one is quite common. Okay, metal alloys, ceramic glasses, and so on. Okay, ceramics you can make an artificial tools. Okay, metal alloys, hip and joints, and then you have uh, polymer and elastomer, so on. And then over here, okay, this one is related for your program, and industrial design. So of course, I'm not going to explain about this one. So over here, engineers versus materials. So a perspective of the world of materials and processes. And then you need to understand actually material properties and their origins. Access information, you need to know how to get the information. Okay, information and tools for the comparison and selection, which is how to get the MSDS. For example, if you buy a chemical, you need to know the material safety data sheet and so on. And then ability to select those best materials depending on the design requirement. Okay, here's about the material selection. Actually, not many people, actually manufacturers faces a problem to select the very best material to make a product, okay, or fit the purpose. Okay, for example, if you want to make an economical yet sturdy, design good looking chair, for example, then you need to choose the right material. Okay, choose the right material based on the design requirement. For example, the chair need to be withstand the load of 120 kilogram. My weight is 114, almost there, but 120 kilogram. So based on that particular design, you have to calculate the maximum loading, maximum stress, compression stress, tensile stress, and so on. Then you need to decide what kind of material that you can use. Of course, you can use the best material. For example, oh, the chair made from titanium alloy. Very nice, sleek, very shiny, but it's very expensive. Probably cost you like 3,000 ringgit and so on. So it's the final practical decision in the engineering design process and can determine that design ultimate success or failure. Of course, when you decide to choose the material, I mean, whenever you want to produce it and then you want to sell it, of course, you need to sell the material, sell the product, of course. So if you want to sell the product, people you need to know the target customer target, okay, target customer, for example, B40, M40, and T20, and so on. Okay, rural area, urban area, suburban, that kind of thing you need to know. Of course, in the very technical part, for example, the if you want to make a pressure vessel, then that pressure vessel need to be used with various kind of chemical, for example, alkaline chemicals, and then you can have hydrocarbon, and then you can have various kind of pressure involved inside the pressure vessel and so on. So you need to know various kind of properties. For example, mechanical, obviously, thermal, yes, chemical, not so much, electrical, depending on the application. Okay. Okay, over here, systematic selection of the best material for a given application begins with the properties and cost candidate material. So of course, you have a table of material. So you need to jot down or you need to short down what kind of the properties that you need to know prior from the selection. Based on this one, you need to make a ranking. For example, material A is having a higher tensile strength, and then but the cost is very high. Material B, you have a medium tensile strength, but the cost is so-so. And then you can have material C, the material the tensile strength is very low, but the cost is quite very cheap. So that kind of thing you need to compare side by side. Of course, it's not just tensile strength and also the cost. Of course, you need to have a list of condition or list of material properties that you need to consider, okay, before you make into a table of ranking. I think in PDM you can get the house of quality, almost similar thing in the material selection, but material selection is making a product from scratch. Okay, for example, over here you can have thermal blanket. So what are the requirements to make? Okay, as for the thermal blanket, for example, okay, the thermal blanket is actually a material, or the purpose of the blanket is actually to retain the temperature of an object. Okay, for example, your body. For example, the pressure vessel. For example, another one is the uh, pipe with the hydrocarbon. Okay, hydrocarbon flow. For example, the for the oil and gas piping, you have hydrocarbon flow in the pipe. Usually, the temperature for the hydrocarbon moving in the pipe will be like 200 degrees and above. So to prevent this hydrocarbon to solidify in the pipes, you need to have a thermal blanket, okay, which they call insulator or insulation lah. Okay, so of course, the properties of the insulator need to be the worst. Okay, I mean poor is okay, but worst thermal conductivity. They use glass inside it, glass wool. Okay, you know glass have a very bad thermal conductivity. Not bad in the bad way, but bad in the good way. Okay, poor thermal conductivity in order to prevent the heat. Okay, to retain the heat inside the pump, inside the pipe. So what material can be used? Is it polymer? Is it metal? Metal, obviously, you have a high conductivity. Okay, electrical conductivity and electrical conductivity and also thermal conductivity. Polymer, you can use that one, but you have a very low thermal resistance because polymer as well, as much as you know, you have a very low melting point. So if you use either hydrocarbon pipe, so just put it and then you just melt it. Cotton, okay, probably a best way to use cotton for the insulator for the pipe, but cotton itself is not enough because it easily broken by the atmospheric condition. That means by water, by physical, and so on. How about polyurethane? Polyurethane, you can use it, but not in high temperature. In car, probably you can use, but in for the a temperature above 200 degrees, probably you can use. PVC, maximum 130 degrees. Nylon, no. So, for example, the hydrocarbon pipe, probably you need to use uh, glass wool. Actually, it's not just glass. The cheapest one is they call it rock wool. Okay, they're actually composite. So for the thermal blanket, you have a various kind of material, but depending on what temperature that you want to use it. Okay, 200 degrees, 1000 degrees, and so on. So for the material selection, generally there are two separate decisions to be made. So which general type of material is appropriate, which is in terms of material universe. For example, you want to make a chair, simple analogy, chair. You want to make it from wood, you want to make it from fiberglass or composite, or you want to make it based on the design itself. For example, want to make it the body from the metal or the body from plastic and so on. And then the second one is the best specific material within that category must be found. For example, laptop, you can use aluminium, you can use plastic for the cover, for the casing for the laptop, or you can use magnesium alloy. So it depends. If you use magnesium alloy, so it's considered as a very light material, considerable light material, uh, have a sufficient shear strength or bending strength compared to aluminium, and then you can have a very good heat transfer for the magnesium alloy because in for the laptop you need to remove the heat inside the laptop and so on. Okay, Another 2-minute question. Okay, in pairs, identify a product which has undergone evolution in the materials used and justify the phenomenon briefly. Identify product which has undergone evolution. This one obviously like handphone most obvious okay, because previous one the handphones weighs like 1.5 kilo. Okay, you can use it as a dispense tool, and for example the later one will be made from plastic and so on. So of course this one is the example in this chapter, which is the evolution of vacuum cleaner. So as I mentioned before, the previous vacuum cleaner is actually made from steel, and then you can have pipes connecting with it, and then you have to use your hand or use your foot to suck out all the dust and so on. Here the ancestor for the vacuum cleaner. I'm not sure over here where is the part for the pump. Okay, here is the suction tube, then connected to a trap over here. Here is the trap. Okay, and then over here, I'm not sure. But actually inside over here, you have a container for the waste, and then you have the vacuum part of that vacuum cleaner. And then over here is 1950, during the baby boom generation. You have a Hoover cleaner. Probably you might not hear this one, this brand, but Hoover is quite famous during the 80s, 70s, 80s. My mom have this kind of vacuum cleaner. It still can be used till now. It's already like 40 years. They buy in 1980. I'm born in 1983. So it's like 40 years. Still can be used. But nowadays materials, nowadays product, you get they design the product to be lasting like 5 to 10 years only. Okay, previously they make a car to be last for 40 years and so on. So this is the comparison between 1950 and 1905 vacuum cleaner. So from here we can see that the design obviously changes. Here you can very have a simple cylindrical plus the cubicle part of the vacuum cleaner. Over here you just have a very simple cylindrical shape with a vacuum motor over here. So here made from the wood, canvas, leather, rubber and so on, or steel. Okay, here you can have electrical powered vacuum cleaner in 1950, and then you can have the vacuum cleaner is actually very heavy. It's considered heavy. Previously they consider this one is heavy because they made from the steel. Okay, so but nowadays the vacuum cleaner is made from the plastics, polycarbonate and so on. Very robust material, like yet lightweight, and then you can have a sufficient vacuum and so on. So here's the 1980s onward for the vacuum cleaner. You can have a very limited amount of metal component over there, which include the vacuum part and also the uh, the hose and so on. But nowadays you can have a various type. So you can have a robot, okay, robot vacuum. Okay, you can have a Dyson one. Okay, this one is like 2,000 ringgit. Okay, so you can have a various range. For example, the cheapest one is like 150 ringgit, and then the most expensive one is like 2,000 to 3,000 ringgit and so on. So that kind of thing evolved from 1905 to the current 2020, and this one is already 2020, right? So of course, materials usage over here is changed rapidly. Over here, metals, plastic, and here become purely more on plastics. Even the blade over here made from plastics. Here's another example for the evaluation of materials in products. You can have a steel kettle, bronze kettle, plastic kettle. Okay, all have the same function to heat water and to retain water inside it. And then also from cameras, the earliest ancestor of camera you can have made from wood and brass lens and so on. And then later on, nowadays you can have handphone as your phone, have your as your camera. So most likely only this kind of camera used for paparazzi and so on. You need to have a significant amount of magnification. For example, you can use it for to observe moon and so on, that kind of thing. But nowadays camera is very compact and then easy can be fitted into the smartphone. So the material itself also changes. You have polycarbonate, you can have ABS, you can have many kind of things. Over here, you have a lot of material. For example, the screen itself is made from the call it gorilla glass and so on. And then the screen is made from the OLED. Nowadays, you can use OLED. In 2003, they just theoretically make it into organic LED screen, but nowadays it's very quite common. Then the processor is made from the semiconductor and so on. Of course, you have a digital camera compared to the mechanical camera. So the demise, for example, the demise of the Kodak company using film because they do not want to venture to the digital camera. So that kind of thing for the material selection is very important for industries. You miss something very high in high technology, and then you can get lost forever. So paint also have a different kind of material used. Okay, previously in the end of the 19th century, the Wilbur Wright brother probably make it from wood and also some of the steel wires, cables, and so on. And then they make it into this kind of plane, which is in from in 1930s above and so on, made from steel, not steel, which is from aluminium. And then over here, for example, Boeing 787 is made completely from, not completely the body, the fuselage, the body of the aeroplane is made from the carbon fiber. Sorry, not carbon fiber. I'm not sure which they call it composites. They call it pre-preg composites. So they have to bake it bulk by bulk. So this actually you need to move this component and this component and this component by section, a big section. So I have been in the factory making this Boeing 787. They have a several thousand acres of land to be used to make this kind of plane. So each of the plane sometimes made from the different company. For example, in Malaysia, they make this kind of body, okay, fuselage. Not so big because in CTRM, for example, just make the fuselage and so on. And then this kind of material also different refractory materials, jet engines, probably Rolls Royce and so on. Over here, uh, different kind of material, okay, and so on. But mostly in the fuselage is made from composite. So you can have a very lightweight aeroplane and then higher efficiency of fuel efficiency, of course, the nowadays to reduce the use of the hydrocarbon inside transportation and so on. Of course, there are problems to make this one because if you break something over here, then you need to change the whole fuselage. Okay, because this one is made into a large, very large panel, not just simple panels, hand layout like boats and so on, but this one is very huge. And then this one, the development of car designs. Of course, if you make some product, then you need to have a decent design in the uh, depending on the not depending on the it's actually when you want to make it much more eye-catching. Okay, previously cars is like just like this. You have wheels, and then you have seat, and then you have engine, and so on like this. Okay, very simple design. But after 50s, then people want to have a very styles, for example, over here, okay, probably this one is Cadillac, not a Cadillac, it's actually American muscle that you have 3000 liters, 3000 cc's of engine and so on. But nowadays you can have a very compact design, and then to increase the optimum usage of the space inside for the cabin, and then the engine itself need to be the minuscule, and then of course you need to have a sufficient strength, and then also good design, of course, and so on. Then, of course, your phone. Okay, this little baby over here is very heavy. Yeah, it's like 1 or 2 kilos. People to use this phone and then bring the whole battery with them. The whole battery is like the LED battery in your car, for example. Same almost the same size. Okay, nowadays we use this one. Okay, so the battery become much more compact. Over here you need to use nickel cadmium battery, and over here you can use lithium ion battery. So lithium ion battery, you have a very higher density energy, high energy density compared to this one. This one you have to combine a lot of nickel cadmium into series and so on. So the application also depends. Over here, you just might able to save numbers and call out and call in. Over here, you can just anything, almost anything. Okay. During my time, I use this one, Nokia 3210 or 3310, the legendary. Okay. And then over here, during the phone era, okay, smartphone era, people tend to use high technology or very fast processor, more like a computer in palm of your hand and so on. Then you can also have a various design over here, various design of chairs. Obviously, you don't want to buy this kind of chair. I mean, it's quite expensive. Stainless steel chairs, easy to increase the heat, and also it's not that comfortable. But you can combine the aesthetic value into your products. Okay, aesthetic means that this kind of weird design is aesthetic. But in form of functionality or comfortability, probably this one is much more better. Okay, compared to these three. I'm not sure how to sit over here. This one is okay. Cardboard. Okay, they combine it with glue and then you preheat it and then you make it into similar like a glass fiber. Okay, glass fiber composite strength. That kind of thing made from cardboard. Actually, they're deep into glue and then you paste the epoxy glue on the cardboard and then so that you can maintain this kind of structure as well as the strength. Over here, coconut fiber probably can be used inside the cushion. Okay. Here, carbon fiber not so nice to be used as chair, but it can be used. Okay, probably will cost you like 2,000 ringgit like that. And then also you have a material type for the lamp, table lamp actually. Okay, table lamp or chandelier. Okay, this one. Okay, serve the purpose because you have a still as a reflector as well as uh, it become much more beautiful when you light it on during the night. Okay, over here is ceramics made from ceramics. Okay, probably best to probably good design, and then you can reduce the risk of being electrocuted. Okay, and then this one made from glass, not sure. Over here probably just for the aesthetic only, but not so tough because made of glass. Bamboo is okay, very robust material. Okay, and so on. Bicycle also, when you go for the conventional way, my steel, and then currently we use aluminium. Previously the bicycle is very heavy when you ride your grandparents bicycle is like quite tough okay, but it can last very long time like 20 years like that Aluminium also can be last a long time because the aluminium itself is very corrosion resistant material. Of course, you can have a cast magnesium over here for the uh, extreme sport or for the lightweight. Okay, and then here is hand layout carbon fiber. Is this one is very heavy, very light and very expensive. Okay, this one if you break it and then you need, if you break this part, then you need to change the whole part over here, same as well as this tire. Okay, this wheel over here. Okay, the tire probably made from rubber, synthetic rubber, but the frame or the rim is made from carbon fiber, but it's very brittle. Not very brittle, but sufficiently brittle. Okay, why material selection is so important? Okay, over here, the Titanic itself, I think you already see the movie and then also seen the documentary about this humongous type of vessel. Of course, inside this one, you have a lot of steel to be used over here in the hull over here. Okay, so over here, it's actually they have a safety mechanism built in this Titanic, but actually they have a double wall. The first wall is the outer part. In the inner wall is to prevent the water from going inside if you have the leak outside in the outer wall. Actually have two wall, two steel wall, two wall. So as for the Titanic, as you know, they hit icebergs. So the failure of the or the tragedy of the Titanic is mainly caused from the human error. Okay, machines or and so on is doesn't make mistake. They use and to be used and fail if we overuse, abuse this one. So if you know that the material for the Titanic is steel, whenever you can have temperature, if you use this steel in very low temperature because Titanic crashed to the iceberg, the temperature is minus. Okay, minus means that like minus 10 degrees, minus 15 degrees. Okay, that temperature influence the toughness of the hull of course the toughness influence the toughness of the steel wall. Okay, for this hull, actually it make the hull much more brittle. So when this ship when this ship struck the iceberg and then it just break through. Okay, that kind of thing happen. Oh, this one. Oh, okay. Continue from the previous slide. Okay, actually the Titanic sank because the sea condition is too good. The condition that time because it's very dark, no wind, no waves, no swell, and so on. Very rare. And then the material itself become much more brittle at very low temperature. Okay, very low temperature. So it sank in 5 seconds only. Another example for the catastrophic failure of materials, okay, is the infamous stadium in, I think, in Terengganu, where the original cost is very much higher compared to the building cost, actual building cost over here. Okay, so I think that I'm not sure what kind of material they use, but they actually changed the material to the cheaper material, which is having a low strength in mechanical strength, obviously, yeah, so that you can have this catastrophic failure. So stadium over here, a design is very perfect. Can have a very perfect design, but if you choose the worst material for it, and then you will crumble easily. As for the summary for this chapter, okay, the first one is the competitive design requires the innovative use of new materials and the clever exploitation of their special properties, both engineering and aesthetic. You need to have both engineer, I mean, both mechanically suitable or mechanically sufficient strength to be used and eye-catching, which is aesthetic. And then many have failed to innovative and exploit lead to extinction. Such example, for example, the Kodak company, they uh, refuse to use the called digital camera technology. Instead, they using the conventional film technology, so they perish. And then also the optimum use of material design. Means material design means which include design requirements to the end of the product performance. I think that's all for today. Don't forget to comment. Actually, comment in the you learn. Then you can also tick your attendance in the ULETs. Okay, thank you very much and have a good day.